Hi everybody, we're going to continue our work with graphing quadratics, and we're going to actually work with graphing the quadratic using the intercepts. This is actually called the intercept form. Whoops, let's spell that correctly. Intercept form of a quadratic. And you'll notice that it looks like it's been factored. In fact, it is in factored form. That's what we call intercept form. This quadratic, if I were to multiply the two binomials back together, would be x squared minus 15x plus 56 equals 0. We're going to actually use it in factored form to find the place where the quadratic passes through the x-axis. So when we're talking about intercept form, we're talking about working with the x-axis as opposed to the y-axis. I want to remind you that the x-axis, let's take a quick look at a coordinate plane here. The x-axis, of course, is the place on the graph where y equals 0. It's the line on the graph where y equals 0. That's because you haven't moved up or down away from the x-axis. So y equals 0 all along this line. You may recall that when we were working with trying to find the y-intercept, that is the place where x equals 0, and that's because we haven't moved right or left. For these, we're going to be working along the x-axis where y equals 0. It's important to know that because you'll notice that we have our equations set equal to 0. Normally we see y here, but we have purposely set these equations equal to 0 because we are specifically looking for those values of x where the graph crosses through the x-axis. All right, so we're going to put this back into its factored form, x minus 7 times the quantity x minus 8 equals 0. Now, you might remember the zero product property. You might not, but the zero product property says that when you multiply something times something and the product is equal to 0, that means that we have factors of 0, or at least one factor of 0. In this case, both of these factors are going to equal 0 in order to get a product of 0. So that means that we are going to say that x minus 7 equals 0 and x minus 8. X minus 8 equals 0. And if that's true, that means that x is 7 and x is 8. And those are the two places on the graph where our quadratic is going to pass through the x-intercept. So I'm going to actually graph those points where x is 7 and 8. They're going to be awfully close to each other. 1, 2, 3, 4, 5, 6, 7, and 8. I could have gone by 2's, but we'll leave it like this for now. So those are the two places where we know the quadratic passes through. It's going to probably barely dip below that x-intercept. So now let's take a look at this one more time. We know we're looking for a vertex point. Now remember, the vertex point is going to be on the axis of symmetry. And the axis of symmetry, let's take a look at our graph again, is halfway in between. It's going to be halfway in between these 2 points. And the reason we know it's going to be halfway in between these 2 points is because these 2 points are reflective of each other. They're at the same y value, so they're reflective of each other, so they're equidistant to the axis of symmetry. That means that this line is halfway between the value of 7 and 8. Halfway between the value of 7 and 8. That means that it's really the axis of symmetry is going to be the average of those two numbers of 7 and 8. So that means that we get 15 over 2 or 7.5, 7.5. So on our graph, our axis of symmetry, that vertical line, is where x equals 7.5 or 7.5. That's very helpful to know because now we need to find the actual y value, because remember, the axis of symmetry is the x value of our vertex point. So we know that the vertex point has an x value of 15 over 2 or 7.5. Now we need to find the y value. So what we're going to do is we're going to take our quadratic in factored form again, but we're going to replace the y, or the 0, with y and try to solve for it. Minus 7 times x minus 8 and set it equal to y. We're going to replace the x's with 15 halves. And now we're going to have to actually find a common denominator for each of these binomials. That would be 15 halves minus 14 halves, and then 15 halves minus 16 halves. This one will equal 1/2. This one will equal negative 1/2. And so when we multiply, we get that y equals negative 1/4. Okay, so that means that our vertex point is going to be 15 halves and negative 1/4. Those are the coordinates of the vertex. So I'm going to place that on my graph. And that's going to be, just like I said, just barely below the x-axis here. Now, that's enough to go ahead and graph our parabola. I need to fix this side of it. The only thing I want to make sure that I do is actually label these points. They are awfully close to each other, but we've got 7, 0, 8, 0, and then this guy is 15 halves, negative 1/2, just to make sure that we've got everything labeled that we can.